It wasn't a very good Star Trek Next Generation show, but it's my favorite line, perhaps because it has a real manic kind of feel to it, was I see the universe as a single equation, and it is so simple. That was said by Barclay, Lieutenant Broccoli, in The Next Generation. It was actually a stupid show. The ending was stupid, but I liked the line. And I was thinking about the different ways that physicists try to envision the universe in terms of unified field theories and TOES, theories of everything. And what's interesting is that they use different analogies, metaphors, and motifs to help get a grasp of what's going on. Like string theory or M theory, membrane theory, uses the idea of oscillating membranes, and there are certain vibrational modes that can exist. And they're looking for something that has a complexity, but an underlying simplicity that will generate all this weird phenomena that's in the universe. Another one which I really like is E8 theory, which is a beautiful geometric theory. And if you're interested in that, I mean, it's an alternative of theory of everything to string theory. Very geometric. And it's in the December Scientific American, along with an article about hallucinogenic therapy and its potential. I've taken a lot of hallucinogens. I always thought that they're just, they're probably not going to be effective in therapy, but they've gotten some really interesting results, initial results, and so it's worth a read if you care for that. Also on those theories of everything, there's loop quantum gravity, and Roger Penrose is one of the guys that does that. He's principally a mathematician and then a physicist, and that doesn't have as many analogies and stuff as E8. E8 uses the analogy of a twisted fiber, and when you twist it, you get all these different patterns, and those are responsible for describing the different particles and the forces, the fields that mediate between the particles. But anyway, the interesting thing is there are all these different motifs that are wonderfully reoccurrent in science across a whole range of scales. I mean, certainly you have conservation, you have unification, just a whole panoply of things. But one of the themes is waves, and you could have a wave on water, you could have a wave on string, you can have sound waves, and they have certain properties, a certain aspect to them, a wavelength, a frequency, a speed of motion, and all. And what's interesting is that they work pretty good in our everyday world, and the equations for all these waves are principally the same. But then you take it further. For instance, in the early part of the 20th century, there was a debate about electromagnetic waves, and all the waves we'd known about before that, all those waves required a medium to travel through, whether it was water, whether it was air, whether it was a solid, it didn't matter. And most people thought, heck, you have to have a medium, because that was our experience. That's what we were basing the idea of waves on. And so there were problems with there being a media out in space. They call it the semi-luminous ether. They just said, they made it up and said, it's got to be there because all the other waves are like that. But it turned out there was an experiment by Michelson and Morley, and they did an interferometer experiment where they were able to definitively determine that there was no semi-luminous ether. And it was quite a remarkable thing because it was just a different type of wave. How can a wave exist without a medium? And it turned out that the electro and the magnetic field was actually propagating itself. And so our notion of wave changed a little bit. But at the same time, we found out that there were other kinds of waves. I mean, it's remarkable that this idea of a wave, this oscillation that exists on all these different levels, was carried through even further. And we described the probability of finding electrons by using wave equations that are the same equations for a wave on a string or a sound wave. They're the same. They're sine wave equations. They're the same equations. And yet, now we're not talking about not having a medium. We're talking about the wave not even having physicality. The waves are, as far as we know, waves of probability. And that's the cool thing about this, because it gets to the notion is that these analogies, when you take them further and further, get further and further away from our everyday experience. And yet these probability waves, which describe electronic orbitals, are like no other waves we've ever heard of. And the waves that occur in string theory, these oscillations of these strings, well, they're the same frickin' equations. And yet, what are we talking about? Are there really strings there? I mean, it's a metaphor. It's an analogy. And yet those equations still work. And that happens a lot. I mean, not just with waves, but that's what I'm going on about. And what's interesting is that we evolved in a certain environment under certain conditions that made it hard to grasp things like relativity. We don't imagine mass changing as things move. We don't imagine length contracting. We don't imagine energy changing with relative motion or momentum changing and all those things that go along with relativity. They're counterintuitive. But then the further we go with quantum mechanics and all, the more counterintuitive things get. And the interesting thing about that is that things begin to seem like they're just mathematical. I mean, like if you look at the spooky action over a distance, which Einstein talked about, which is entanglement, when you have quantum objects that need not be microscopic or subatomic. They can be macroscopic, like a Einstein condensate, which you can see, but they don't behave classically. They behave weird. They behave like waves. It's not just electrons. I mean, the whole frickin' universe behaves this way. If you think that it's just the big world out here that doesn't, behave weird, you're wrong. It's just that they're hard to see these effects. They're still there, but we can create them macroscopically. We've done that for a while. People just haven't really thought about that much because, we're more interested in Paris Hilton and maybe what Hillary Clinton wore that didn't look right. But I mean, it's fascinating because one thinks that, okay, is there something there? And in other words, as we approach things that are further and further from our everyday understanding of the way things are, is it that there is something there? It's not just mathematical. There's something there, but we can't just grasp it because we can't make an analogy. We're doing the best we can. We're creating these models which we think will conform to what we know, and we're using what we know to build them on these models. And in most cases, in some cases, people are doing pretty much mathematical things and saying we're not really going to talk about what it is so much. We're going to say this is how it behaves mathematically. But I mean, that's sort of the direction that we're going in. And the question is that satisfying? Well, or does that matter? I mean, people have a problem with that. That was Einstein's big thing. I just lost my light here. Let me get that back. There we go. I'm back. Okay, it takes 10 minutes. It goes off. I didn't realize that I had that set. Well, it's 9 minutes and stuff. But anyway, so the thing is that we're developing all these ideas about the universe, and the question is are we going to be able to reconcile that with what we know? I mean, with waves, it's gotten to the point where we don't really know what we're talking about. I mean, we're calling them strings, or we're calling them fibers, or hell, man, we're throwing away space and time and we're creating other structures, but they're purely mathematical. And I don't know. It's just kind of interesting. I mean, I've thought there people are talking about the notion where ultimately, and I brought this up in a video just casually because it was on my mind, that ultimately that the universe is mathematical. I mean, well, yeah, it can be described mathematically, but some people have been talking about it being essentially informational and not physical on a primary level. This is a radical notion. This is just like that these waves, these probability waves, are essentially just mathematical, that they're not based on physicality. And yet that goes against almost everything we feel. So, I don't know. Some thoughts I've been having, because I have these thoughts, I can't help it. And I'm trying to inflict them on you. But I would like to see the universe as a single equation, and I doubt it would be so simple.